So the problem with circular motion, there's a problem very much like this in the book. So let's work it out. A good diagram is going to be very important here, so let me do my best. Draw the Ferris wheel as a circle, and then so we'll have the kid on the seat down here, and then we're going to be interested in what's happening at three different places: the bottom, midway between the top and the bottom, and the side. This Ferris wheel has a radius of 12 meters. And let's see, it makes 2.5 revolutions per minute. So omega is 2.5 revolutions per minute. Let me convert that into radians per second. So that's 0.262 radians per second. Okay. So let's start with part A, the lowest point in the motion. What is the magnitude of the normal force? So let's consider the forces that are present at the lowest point in the motion. We have the normal force, we have gravity, and we have the centrifugal force. Right, gravity and the centrifugal force point radially outward, and our convention, of course, is that radially outward is positive and radially inward is negative for our forces. And so the way we're going to do it is we're going to consider the sum of all radial forces. That's equal to minus the normal force plus gravity plus centrifugal force is equal to 0. Now we've talked about this, that you could take this mv squared over r and move it over to the other side and call it a centripetal acceleration if you want, but I do it with centrifugal force. Alright, so if I isolate the normal force, I get that the normal force is equal to mg plus mv squared over r. And of course, mv squared over r can also be written as mr omega squared, because v equals r omega. So I can make that substitution. Okay, working out mg is 343, because the mass is 35 kilograms, so 35 times 9.8. And then mr omega squared is 29. So that adds up to 370 newtons. There's the normal force at the bottom of the Ferris wheel. Part B asks midway between the top and the bottom, what is the magnitude and direction of the force of static friction? Okay, so let's consider the forces here. So we've got normal force and gravity. And then there's the centrifugal force, which pushes radially outward, and then there has to be some kind of friction, some kind of static friction holding the guy in place. And we're not told, it's not a threshold problem. I can't say that the force of static friction is equal to mu sub s times the normal force, right? Right, I can't say that. For two reasons. One is that I'm not told that he's just about to move. And secondly, I have no idea what mu sub s is. So that's pretty useless to me. Instead, let me consider the sum of all radial forces, and that's going to be minus the force of static friction plus mv squared over r is equal to 0. And I can, right, so now I can just solve for the force of static friction. It's mr omega squared, which is 29 newtons. And you can see the direction here with the force of static friction points radially inward. So there's the magnitude and direction of the force of static friction for part B. And then for part C, it says at the top of the motion, what's the normal force? Okay, so again, let's draw our forces. So we've got the normal force, gravity, and then the centrifugal force, which points outward, radially outward again. So our equation then, again, radially outward things are positive and radially inward things are negative. So I've got normal force plus mg, plus, let me start over. I got normal force minus mg plus mv squared over r. Right, normal force is positive, mv squared over r is positive, and mg is negative. Compare to this up here. Right, that what's happened is basically the normal force and gravity are still, they still have opposite signs, but the centrifugal force has the same sign because it still points radially outward. Okay, so let's see. That gives me that the normal force is equal to mg minus mv squared over r, or mg minus mr omega squared, which is 343 minus 29, right? Again, compared to what my result was up here. Here I got the normal force is the combination of the two. Here the normal force is the difference between the two. So that's 310 newtons.